never know everything that's happening inside your systems, nor do you want to, nor should you have to. There is a lot going on in there. The good news is we have observability. Observability is about giving yourself and your team the ability to understand what's happening inside your system at any given moment, not just the what, but the why and the how. In this video, we're diving into what modern observability is, how it's different from previous generations of telemetry tooling, and why we need it in order to drive engineering and business success. The term observability comes from control systems theory, where it refers to how well you can understand the inner workings of a system just by observing its outputs. Almost a decade ago, we borrowed the term in the software industry and began using it here to explain how an emerging generation of tools and best practices were different from the reigning paradigms of the day, metrics and logs. These days, people tend to use observability as a generic term for anything and everything related to telemetry and software. In this introduction, though, we're going to use it more as it was originally intended, to help distinguish modern observability from the much more traditional 3 pillars approach, which we'll refer to in this piece as monitoring. Wanting to understand what our systems are doing isn't exactly new. Back when metrics and logs were the primary forms of telemetry, we had dashboards full of static graphs, things like work rates, memory usage, or CPU saturation and spikes. And that worked well enough, really, when our systems were simple, predictable, and relatively static. Today, though, we are working with modern distributed systems and event-driven architectures, which are infinitely more complex. And with complexity comes unpredictability. And this demands a different approach, one that is much more exploratory and open-ended. Monitoring and observability often get lumped together, but they serve different purposes. Monitoring is mostly about the when, tracking predefined metrics, conditions, and system health indicators. It's reactive. It surfaces issues that we knew might happen through alerts and dashboards. Observability, on the other hand, is really much more about the why and the how. Observability gives you the ability to dive much deeper into rich telemetry data, logs, traces, metrics, relational data, to understand system behavior at a far more granular level. It allows teams to ask questions that they weren't prepared to ask, that they didn't expect to have. Another way to think about this is that monitoring is very much an ops tool focused on operational outcomes, whereas observability is about how you develop and understand your software across the entire software development lifecycle. It's not just about whether this code is slow or it has bugs. It's about validating whether the code that you wrote is doing what you thought it would, what you meant it to do, and about understanding what kind of experience every user is having. With observability, we can answer really complex questions. We can answer things like how many users are affected by this outage, or what was this specific user's experience during this time, or where exactly is this request failing and why? Because it tells us much more about why something happened. It allows application engineers to rapidly debug production systems, but it's also usable for all of the other things that we need to understand that are not just errors and bugs and outages. Turns out there are a lot of things that we need to understand about complex systems and software because things are changing all the time, and it's not just bugs and errors. Observability and monitoring emphasize different kinds of telemetry data, each fit for their purpose. Monitoring focuses on metrics, while observability usually focuses on very detailed logs or trace bands, all structured data, right? As well as metrics, but they're all correlated. And the differentiator is in how that data gets used. Monitoring relies on tracking known areas of interest in your data, structured and aggregated data, like error rates, CPU usage, or request latency to detect known issues and trigger alerts. For example, if there was an infrastructure incident last week and it was triggered by high cache volumes and it caused servers to restart, engineering teams might then deploy a new alert based on a certain memory threshold to let them know the next time it happens. Monitoring really excels at this use case, providing early warnings for predefined problems, and it's more reactive in nature. On the other hand, observability includes all this, but it takes it a step further. It enables much more exploratory, open-ended investigation into intersection of software, systems, and users. And as such, it's more proactive in nature. Engineers use this detailed, context-rich telemetry data to understand and track the ripple effects of user activity, software changes, the behavior of individual users or groups of users, and how they interact with the code that you've written. Observability tools allow engineers to pose new questions about system behavior, trace execution paths, or identify anomalies that monitoring alone can't surface, especially when it comes to these complex, modern distributed systems with lots of users making changes to and interacting with the system at once. The emphasis again is on the why, not just the what. There's actually a lot of stuff to understand. It's not just errors. Okay, now I think you get the gist of what observability is. However, to really understand it and apply it, we need to dig a bit deeper into the purpose of observability for not only software teams, but for the business as a whole. First, engineering teams need to be able to ship fast and understand how the code that they have written translates into customer experience as quickly as possible. The heart of engineering excellence is all about fast feedback loops. Observability itself is actually a feedback loop. It is the sense-making of production systems. When your observability is poor or weak or partial, it can feel a lot like working in the dark. Everything you do slows down, and your confidence in what you have done is low, or should be low. When your observability improves, you'll find that you can move swiftly, consistently, and with confidence. Second, beyond engineering, observability drives business success, not only by improving system reliability and performance, but also by aligning engineering pain with customer pain. It helps organizations understand and act on the needs of the customer. When the entire company values observability, it really effectively bridges the gap between engineering and business, ensuring long-term stability and growth. That's a wrap. Okay, here are the primary takeaways. Monitoring tells you when something goes wrong by tracking predefined metrics, while observability can help you understand the why and how behind system behavior. Monitoring is essentially about how you operate your code, while observability is about how you build, maintain, and understand your software over the long run. With observability, all your engineering teams can share access to the same rich data, which breaks silos and improves coordination when diagnosing and resolving incidents and understanding all the complex intersecting parts. Good engineering relies on fast feedback loops, and observability is the feedback loop at the heart of fast, reliable software delivery. Beyond engineering, observability supports customer satisfaction and business success by improving your system's reliability, stability, and performance.